Hello students, in this video we'll be seeing few of the MCQs related to chemical bonding. See the first question. Lattice energy of BCO3, MgCO3 and CaCO3 are in the order. Let us first write the atoms which are involved in this particular given sequence because carbonate radical is same. So let us focus on beryllium, magnesium and calcium. Now students, if you see the atomic size, beryllium is smaller as compared to magnesium and magnesium is smaller as compared to calcium. Now here they are asking about lattice energy. Lattice energy directly depends upon the solvation or the hydration. What is solvation or hydration? It is the ability of that particular atom or the cation or the anion to get surrounded by the solvent. If the solvent is water, you call it hydration. Otherwise, for any other solvent, you call it solvation. Now students, always remember, smaller the size of the cation or the ion, smaller the size of the cation or the atom, more is the solvation or hydration. More the solvation or hydration, more is the lattice energy. And according to this, if you see the size, beryllium being smaller in size, it will be solvated more and therefore its lattice energy will be high. And therefore, the lattice energy will follow the sequence, that is BeCO3 will have more lattice energy as compared to MgCO3 and then CaCO3. So your answer is first option. Let's see the second question. Lattice energy of an ionic compound depends upon. Lattice energy of any compound depends upon the size of the atom or the ion or the charge on that ion. Right students? So let us write, that is, lattice energy depends on size of the atom or the ion and the charge on the ion. We consider this for isoelectronic species like you have Na plus, Mg2 plus or L3 plus. They are isoelectronic species. So here the size will be smaller for L3 plus. That is because it has a greater charge. So lattice energy will depend upon the size of the atom and the charge on it. So according to this, the answer is fourth option. Let's see the next question. In which of the following species the bonds are non-directional? Students, you know that ionic bond is always non-directional. So we have to select the option which will show the ionic bond. For any molecule to form an ionic bond, the first condition is that the size of the cation or the electropositive atom must be large, means its ionization potential should be low, and in case of electronegative species, so the size of electronegative atom must be small or its electron gain enthalpy should be high. Then only you can form a very strong ionic bond. Now if you see this ionic bond, size of the electropositive atom must be large. So I have to select because anionic part is same here and therefore what I have to check is nitrogen, rubidium, beryllium and boron. If I see this, then nitrogen is of course from p block, so its size must be small because this is the electropositive element here. If I see rubidium, its size is large. Beryllium and boron, they have small atomic size. So here answer is second option, where rubidium is having more electropositive character and will have low ionization potential. I am not considering the anionic part because they are same for all the options. So where you will find the ionic bond is second option, and that ionic bond of course is the non-directional one. So answer is second option. Let us see the next one. Based on the same concept, let us solve this. Which of the following is least ionic? Now they want a least ionic bond. So for a least ionic bond, the size of the electropositive atom must be small with high ionization enthalpy, and therefore the size of the atom here is small is for beryllium. So the answer here is first option. Let us see the next question. An ionic bond A plus B minus is most likely to be formed when the size of the electropositive atom is large with low IP, and size of electronegative atom must be small with high electron gain enthalpy. So students, on that basis, answer is second option. The ionization energy of A is low and the electron affinity of B is high. Students, if you find this video useful, then please do share with your friends so that they are also benefited. Thank you for watching.